Welcome to In a Nutshell, the podcast dedicated to all things agricultural consulting. I'm Dylan Brush here with soil genius and ag consultant Bill Brush, and we're delighted to accompany you on this journey where we break down the different aspects of agricultural consulting. In each episode, we'll dive into the realm of agriculture through the eyes of Bill Brush, where consultants like Bill play a vital role in empowering farmers, agribusiness, and agricultural organizations. If you're passionate about agriculture, problem solving, and enjoy a little bit of detective work, this podcast is tailor-made for you. So in the last episode, we talked about a lot of the soil structure and the importance of soil structure, and we kind of started to get into how water affects soil structure and the importance of water in that soil structure. And so I would like to ask you just basically, how important is water in finding that good soil structure and getting to that good soil structure?
Yeah, thank you for that intro. And what I really wanted to start with is that everyone understands the importance of water, necessity of it for agriculture and growing any crops, and having sufficient amount of water to be able to make that crop everything it can be. The one thing I always tell a lot of growers is, the only thing worse than poor quality water is no water. You can't grow the crop without water, but we need to find a way to make some of the poor quality water work. There are going to be several episodes coming about water in detail, but I want to dovetail behind the soil structure to understand that without water, we're building soil structure for water. That's what we're building it for, to get air and water into that place where we can create the proper amount of air and water for soil solution and nutrients to travel freely into the plant. So you start with water, and a lot of people, of course, say, well, I really don't irrigate. I'm 100% rainfall, so water really doesn't apply to me or whatever. From volume, they are always out of control whether it rains or doesn't rain, so they're always worried about how much they can control that. And soil structure will help them retain that water a little longer when they need it. But one of the things that people that use rainfall don't really consider is that most rainfall that I've found is going to be on the acid side or acidic. It's pH. I've seen it down in some places where I've been, clear down in New Zealand, down at pH of down at 5.6. And a lot of it's about 6.2 or 6.3. The other thing that people don't also consider a lot of times is just the sheer volume of what water is. If you have essentially about 3 acre-feet of water, just a little over, you're looking at really about 1 million gallons of water applied per acre. So that's 8 million pounds if you use the simple 8 pounds per gallon. So 8 million pounds of that water is getting applied to you. And that can, in its own regards, in its own value there, it can actually put some compaction to it, particularly if it's rainfall. And so with that in mind, I said, now the next thing is, what is that acid pH going to do to your soil? Well, soil weighs about, in the aerobic zone, which we call 6 to 7.5 inches, somewhere in that range. It weighs about 2 million pounds. And at 2 million pounds, you're putting at 8 million pounds, you're putting 4 times the volume of your aerobic zone through there with acidic water. And that acidic water is going to take something with it. It's pure. It's going to want to pull minerals out. And sadly, for most of the time, it's pulling out calcium. And when it does, we begin to erode our soil structure. So I know a lot of people think, well, irrigation water is what he's going to talk about, so I don't have a concern. It's really important that you understand all aspects of water and what, acidic water, even though it's pure, can be too pure. So we start with a simple question I always like to ask clients is it that what's your idea of good water? A lot of times they have a difficult answer to that, and a lot of them will say, well, it's just the rainwater. Well, in most regards, that's a nice source of water, but it can be too pure, which can strip out minerals, I said. And on the other side of that, well, my water's not real good. It's slightly, it's got bicarbonates, it's got a little high pH of 7.5 or 7.6. And so I'm always struggling with it to perform the way I want to. And then we need to find out, if that's the case, what is your water costing you? And how big an impact does good and poor quality water have on your crops? And then, like I said, what is the effect it's having on your soil structure? You spend all this time and effort to get your soil structure correct, and then you come back and you destroy it with nothing you can control, rainfall, or you can't really control the irrigation water you have to use because that's what you've got. And so what is it doing then? And then And then what can I do to improve that water? Because for the most part, water is seldom ideal. We almost never encounter perfect irrigation water. Most irrigation water can be improved, and some water sources cannot be used for sustained crop growth without being chemically modified. We need to actually change the elements in that water to make it be usable. And most labs treat nutrient management as though you are using rainwater, and their testing methods are developed based on rainwater to grow our crops, and that isn't the case on all cases, obviously. So why do we need a water that's a high-performing irrigation water? Because everything we do in crop management depends on an adequate supply of moisture that's available to the crop at the right time. Poor quality water is a limiting factor that diminishes all your other efforts and inputs into your crop. The crop will never be what it could be without good irrigation water.
So just to kind of recap on what Bill was saying, water is extremely important in having a successful crop. Additionally, water can actually cause problems that you may not even think of in the first place, such as, like Bill was saying, compaction, because water in the quantity that is needed to properly saturate crops is very, very heavy. That weight is what causes compaction. Also, depending on what water you get and where you get it from, the water source, like Bill was saying, can also have a great effect on your crop's health. Bill is mentioning how lots of rainwater that he's come across actually tends to be on the more acidic side. Acidic water can actually cause nutrients to be stripped from the soil that you've worked so hard to get while building your soil structure. Bill also mentioned how with irrigation water, you can have it treated in order to prevent some of these things from happening. Now Bill's going to go into a little bit more of the specifics of how important it is to know exactly what is in your water.
Your irrigation water quality really matters. Irrigation water is almost always either taking something with it, in the case of those real ultra pure water, or leaving something behind. So you better know what it is in that water and how it's reacting to it. So a lot of people look at me kind of funny when I tell them, you need to get a sample of your rainwater, particularly if that's your sole source of water. Because they always look at you funny, well, it's rainwater. Find out what it is and what the pH is, because what you need sometimes to do is you've done your calculations, you've determined how much lime or gypsum you've needed to get the proper amounts of calcium, magnesium in the balance to give yourself that proper structure. And you have an opportunity, if you know how much water you're using or about how much water you're using and whether it's acidic or whether it's going to strip something out or leave something behind, you may need to over-apply a little bit of lime to allow for some of it to be leached out with your acidic rainfall. Because your soils are going to tend to take on the chemistry of the irrigation water you're using. And the lower the CEC in the soil, the faster this occurs. Because guess what? There's less clay to change, and it'll change what little clay you have in those sands into something that you don't want it to be. And I tell people this a lot, you really cannot have an effective nutrient management program without taking your irrigation water into account. So we study irrigation water. It's our biggest input by and large, roughly in the millions of pounds. There isn't any other input that you're even close to applying that much. So that's why we look at the study of irrigation water and what we can do to make it work better for us. And the effort you put into learning about irrigation water chemistry will never go out of style. One thing of learning about good things about soil and soil structure and also about water and water chemistry is it really doesn't change much. It's always the same. Once you learn it and have an ability to take it into your everyday work and understand how to make it benefit your crop for your results that you're looking for, it's something you can repeat. Unlike the knowledge sometimes that we gain with ag chemicals, which some chemicals are in vogue, out of vogue, they change from year to year, they change the concentration. You're having to learn a whole new bunch of chemistry every year as it pertains to those different pesticides, herbicides, everything that we use. Your knowledge of irrigation water, though, will serve you basically all the way throughout your career. One of the things I hear a lot of is well, there's not that much, it's only got 180 parts per million. So, that doesn't sound like very much, or, 1 part per million is, not that much, Well, it depends what it is. If you use something like, if you have a little boron in your water and you say, wow, it's only putting in, 1 part per million, but if I apply 8 million pounds of water. That's 8 parts per million of boron, and nobody would be putting in that much boron into their crop. So one of the things we have to know is what is there, and it's much the same as soils. There's really only one good way to find out, and that's to run a water test and find out what's in that water. A good example is there's a lot of irrigation water, pumped water, and even surface water in a lot of cases. But each pound of bicarbonate you find in that water test, and we'll do parts per million, and that turns into pounds, but for every pound of bicarbonate, it's going to tie up a pound of soluble calcium. So you can put on, in a 2.5, 3 acre feet, you can put on 1,200, 1,300 pounds of bicarbonate, and that bicarbonate is going to tie up 1,300 pounds of calcium, which is more than 2 tons of lime. So we need to make sure that we're always on top of what our water's doing and how it will change. A lot of times our irrigation water at the beginning of the season is the best it will be after a winter of snow and rain and runoff, and those have been recharged, as opposed to very, very static and we're just drawing off of it as the summer gets hot and dry, and we get to the end of the year, it could be at the worst point that it is. Everybody knows kind of the symptoms of things like bicarbonates, and they're one of the things that we find a lot in irrigation water. I've talked a little bit. It's a little simpler on rainfall if that's what you're using, because it's relatively pure, and we're just trying to add some mineral back in so that it works well in our soils. But on bicarbonates, it's one of those nasty ones that's leaving something behind and tying up a lot of our soluble calcium. But everybody that's been around a pivot or an irrigation or a sprinkler that's getting it onto your windshield, it'll leave behind that chalky white deposit normally. And that's something that as it dries will plug things up, tie up nutrients, and generally it's kind of insidious because you're going to be irrigating on a regular basis, and it's going to be either tying up or leaving behind something that you don't want.
Now Bill's going to dive deeper into the importance of taking water tests and what exactly to look for in those water tests.
So we look at what potentially are going to be problems in our water, and how do we know they're going to be there or not be there? And it's very similar. You can't fix that you don't know is either in that water or that you can't measure. So we do a water analysis like I was talking about, and what do we look for? The thing that's simpler about water is that it's a much easier analysis to take place, because for the most part, all of the mineralization and minerals, both the anions and cations that are in that water, are basically already in solution. So it's merely of finding the proper machinery that people use at labs to run them through to measure the quantity of the different entities. And what are we looking for? On the cation side, guess what? We're looking for calcium, magnesium, potassium, and sodium. Same thing we're looking on soils, because it's the majority of what you're going to find in those minerals. On the other side, on the anions, however, what we're looking for is bicarbonates, carbonates, sulfates, nitrates primarily, and chlorides. So those 5. And if you look at that water analysis, the one thing you'll notice is the cations and the anions balance out to be 0. And the reason they do is there is no static charge that's free in there, so every anion must be attached to a cation. And that's why the water is not have a charge to it. It's just neutral. So that's what we look at when we're looking at a water analysis. Those are the primary things we look at. We'll also look at pH. We'll also look at how much what we call dissolved solids are in there, to how much it may deposit on your irrigation equipment, etc. And those are the things that we want to look at. But what we face most of the time with irrigation water, I already mentioned this, but it really is the only real problem with rainfall is it's too acidic with no mineralization, so it's going to look and strip minerals out. But the things that can really plug up your irrigation system and can really slow down and tie up calcium, it's going to be things like bicarbonates and carbonates.
Now Bill's going to talk about the difficulty of combating carbonates in your water.
So when you have carbonates, you have a really hard material to get rid of. Carbonates are basically when they get with calcium or magnesium, they form either magnesium carbonate or calcium carbonate. And those two basically are very, very hard structures that take a strong acid to break down and make for a very difficult time. It's almost forces you to do some kind of water treatment. But a bicarbonate is a lot lighter, a lot easier compound to deal with, and it can be tied up with sodium and potassium and both calcium and magnesium. But it can also be broken apart with acid at a lot easier rate. So we look at that carbonate and we hope that you don't have carbonates in your water. We normally find them only when we have higher pHs, somewhere approaching almost to 8 or above 8. Then we begin to see probably carbonates show up. Up until that point, most of those under that pH level are down below and have mostly bicarbonates in them. So how do we neutralize bicarbonates? One of the easiest ways is do nothing, and people always look at me kind of funny. If you are using a certain amount of rainfall during the year that's acidic and you're depositing a lot of bicarbonates onto your soil, that rainwater will take care of it all by itself. So what we do is we kind of build up those bicarbonates and we wash them out with clear water. And that gives it mineralization that it can get to, and it doesn't tie up your calcium quite so much. So a lot of times, you might apply 3 acre-feet of water, and you might get 2 foot, 24 inches of rainfall during your season, and all of a sudden you find out your soils are pretty much balanced and they stay that way. That's the fortunate thing that can happen. We have seen it in heavier rainfall areas when they go through a drought. First thing that happens is the bicarbonates you're using, because you usually use more of your well water or surface water, and it builds up faster, that we need to do some acidification temporary until we get good rainfall again. So we'll use the standard things that we like to use. We'll use a little bit more ammonium-based nitrogen that'll provide some acidity, along with some elemental sulfur, which will basically do some acidification in its conversion to sulfate. So those are the simple things we can do. When it gets to a point where we don't get the rainfall periodic, we're in a much drier climate, or we have a really bad well which is dumping lots and lots of bicarbonates on that soil, we have to look maybe at acidification. That's a whole program in itself, understanding how to do that. But those are like last resorts. I try to do some more of the natural things that we're going to get, credit for our soils as we, without having to take drastic measures. But acidification creates a lot of problems on its own. So it's kind of like my last resort I like to go to. I'd much rather do some of these things that are easier to do with rainfall and balancing back and forth, maybe applying additional calcium in the off seasons to balance me out and get me where I need to.
In this next section, Bill's going to talk about the pH and its importance in water.
I always like to talk a little bit when we get to water about talking about pH. A lot of people talk about pH in soils, and we try to look like we try to get to this perfect nirvana of 6.5 pH. That's exactly where I want to be. And I've seen a lot of very poor quality soils that are 6.5. They aren't balanced at all. It just means the balance of their cations leaves them with a balance of hydrogen, but it doesn't mean your calcium, magnesium are right. It just means you have the right pH. If you look at it, pH is just really a measurement of the hydrogen ions that are present in your soil or your water, whichever one you're measuring. And the pH scale is logarithmic. And what I mean by that, it's like a Richter scale, as the number goes up slightly, the effect goes up tremendously. So, if you have a pH of 6, it's 10 times more acidic than a pH of 7. And a pH of 5 is 100 times more acidic than a pH of 7. So it changes rapidly. So understanding that pH really doesn't on its own mean anything. It's just an indicator. And what I mean by an indicator, I always like to use this analogy. It always seemed to make sense. If you're driving, your truck, your tractor, whatever, and you're driving it in the field, down the road, wherever you're at, and you look down and your temperature gauge starts to rise. Well, that's like your pH. It's just an indicator. It tells you that you have a problem developing or develop, but it doesn't tell you what it is. If your pickup's going down the road, what it could be the fan belt, could be the water pump, could be, the belt broke, the belt fell off, your water pump seized up, you got your radiator plug up, and on and on and on to things that could actually make your temperature rise in your truck. It's the same thing in soils or water. The pH is just an indicator that something is getting it askew from where we want it to be, and what we need to do is find out what it is By itself, it means nothing. It just indicates which direction you want to go. I always tell people in soils, if you have something that's 7 or above in soils on the pH, it tells me that something is taking up more space than it should. Because in that perfect soil and that perfect balance we talked about in the first segment, is we should be around 6.5 to 6.8, somewhere in that area would be where we'd be. So if we aren't, it means something's taken the place of the hydrogen that would be there. So we just have to find what is taking up that space. Why do we have too much of it? And then how do we correct it? Conversely, if we get down to a pH of 6 or below, we know, guess what? We have too much hydrogen and something's missing. So we look to our soils or we look to our waters and see, what are we missing? You look at a rainfall, what you're going to find is you're not going to find any minerals in there. That's what's missing. And so you can add, a little extra calcium that it will mix with your rainwater and make it work properly. Or on the other side, you can say this bicarbonate is driving pH up. What am I going to do with it? I gave you some of the techniques you can use to do that. The one thing you can never do is ignore your water. It's changing all the time. And I mean by that is, I'm here in the Central Valley of California. We had a monster weather year with lots of rainfall, lots of snowfall, made up for a lot of problems and cured a lot of problems in our field. Fields now have been cleansed with pure rainwater, which is what we needed to break down a lot of these bicarbonates and the compounds they had formed and open up that soil and make it drain more like we want it to. So we always are paying attention. But again, it's one of those things where you cannot change what we get rainfall. You can only react to what it's done to your soils and use it for good or find a way to make it better than it currently is. Years of drought create lots of problems because we're going to use whatever water's available. And because of that, with using these off-quality waters, it gets worse and worse with no rainfall to clean it out in between, and that's why we get to the point we get to. And a lot of these yield is lost, but understanding what we can do to make those waters work better is critical. I'll talk more about water in several episodes coming up, but for right now, we'll just want you to understand a lot of people don't look at water for what it is. The biggest input you have in farming, it can be just as bad if it's too pure as it is if it has a lot of dissolved solids into it. And it's understanding the difference in how I apply that to my farm that's going to make me more and more successful. The most important point of sustainability is that the farmer has to make a profit. If what we're growing, we can't get enough volume, enough quality, or the price is not good enough for us to turn a profit, so the rest of the ideas of sustainability don't really matter much. I appreciate the time today. I'm looking forward to now go back in our next several episodes, and we're going to go back to soils and dig in to all the elements and all the nutrients that we need to get the proper fertility into soils and get it to where we'd like it to be.
Thank you again, Bill, for sharing your knowledge on water and how incredibly important it is to having a successful crop. Like you said, we're going to be revisiting many of these topics in future podcast episodes, as well as touching on new ones. So for all you listeners out there, make sure to leave a comment, like, subscribe on YouTube, and share this podcast around. Thank you very much for listening, and stay curious.